Alright, and we're getting started.
What up? Just say it. Make it intro.
Hey guys, Zach Bulky here, and we are.
Alright, so we are looking at exponents to define why any exponent to 0 power equals 1. Alright, so let's start us off. Luis, since you got decimals right there, what's 2 to the 4? 2 to the 4th power.
2 to the 4th power.
Yep, what is that?
2.
It's not 8, I'll tell you that much. What's 2 to the 4th?
32.
16.
Oh yeah! Oh my god!
Moses told you the wrong answer.
I
Alright,
thought it was.
alright, it is 16. Jace, what's 2 to the 3rd?
Oh,
Got
2
decimals right
times
there.
4.
Jace, what's 2 to the 3rd?
That's all I had to do.
9? What is 2 to
2 to the 3rd is
power?
9. That's 3
Oh,
squared.
wait.
Flip it around.
You silly. It's 8.
It's 8.
Oh, I flipped it around.
Lily, what's 2 squared?
4.
No, it was close.
Moses, what's 2 to the 1?
2.
And then 2 to the 0, anything to 0, we just talked about was 1. Alright, let's look at these answers and let's work backwards. We're looking at powers of 2, right? What's 16 divided by 2?
8.
What's 8 divided by 2?
4.
What's 4 divided by 2?
2.
What's 2 divided by 2? So, they change by whatever your base is. We talked about exponents before. This big number is your base. So if I'm working backwards, I divide by whatever my base is, and that's why 2 to the 0 is always 1, or anything to the 0 is always 1. When you work backwards, you divide it by your base. 2 divided by my base is 1. This works no matter what number you have right here. So that's why it's always 1 and not 0. It's kind of weird. Alright, we're going to have to keep that in mind, because we're going to see these every now and then. This isn't the main part of our lesson, but it is a little bit. So the main part of our lesson is going to be about simplifying exponents. I want to know what is 3 to the negative 2, and I didn't put it on here, without exponent, or without decimals, excuse me. Without decimals. So there will be like no decimals this chapter. So I don't want any decimals this chapter. So, we're going to simplify this negative 2 exponent. Because, do you guys know what 3 to the negative 2 is?
No.
You know what 3 squared is, though?
It's
3
6.
squared is 9, right?
9.
So if we can get rid of this negative in our 2, we can figure that out.
I got it.
And what we're going to do is we need to work with fractions. So, right now, I have 3 to the negative 2. It's not a fraction, but I'm going to make it one real quick. And we did this last chapter. How do I think we're at Kinsey. If I'm going to make this 3 to the negative 2 a fraction, what do I put down here? 1. So I'm going to put a 1 down there. And then, to get rid of my negative exponent, we're going to flip the side of the fraction it's on. So it's on the top right now, right? I'm going to put it down on the bottom of my fraction. And when I do that, my negative exponent goes away. So on the bottom, I've got 1. Still, I'm going to go times, because they're going to be timesing together. And instead of 3 to the negative 2, it's going to be 3 squared. Whenever you flip the side of the fraction an exponent is on, the negative goes away. So I flipped it to the bottom, the negative went away. But I got to do a couple of things. Can I have this empty blank on top of my fraction? No. What do I fill it in with? 1. Fill it in for 1. Okay, so on top I've got a 1. And then on the bottom, I can do, what's 3 squared? 9. What's 9 times 1? 3 to the negative 2 is really 1 over 9. Yeah, that's having a hard time talking today. 3 to the negative 2 is really 1 over 9. That's our final answer here. So this is what we're going to be practicing today, is just simplifying negative exponents. So let's look at 5 to the negative 1. It's not a fraction, so I'm going to make it 1 real quick by going like this. And then I'm going to put it from the top to the bottom. I'm going to flip the side it's on. So on the bottom, I'm going to go 1 times 5 to the positive 1 now, because I flipped the side. I got to fill in the top with the number 1, because I can't have an empty spot on my fraction. So I'm going to have 1 on the top, and then on the bottom, I can just calculate this. 5 to the 1 is 5. 5 times 1 is 5. 5 to the negative 1 is really 1 over 5. These next ones are basically the same thing, except they're already a fraction, right? My y to the negative 2 is already on the bottom. but it works the same way. I'm going to flip the side it's on. I'm going to flip it up top. So I've got 1 on top already, times y to the negative 2. I'm going to go y, and because it flipped sides, my negative goes away. And then, do I have anything left on the bottom of this fraction? There's a 1, right? Because I fill it in. But when I flip from the bottom to the top and there's nothing left, does that 1 on the bottom matter? Does that 1 right here matter?
No.
No. So you could put a 1 there, or you could just leave it like 1 times y squared, which we can calculate really quick. The divide by 1 doesn't matter. Does this times 1 matter? No. Really, this is just y squared. And I can't simplify this anymore because I do not know what y is. So this is my final answer on this one. Okay, one more. I have 1 over 4 to the negative 2. It's already a fraction. It's on the bottom, so I got to flip the side. I got to flip it up top. On top, I'm going to go 1 times 4, and this time it's going to be a positive 2 because it got flipped. I do have an empty space on the bottom of my fraction, but that doesn't matter because we fill it in with 1, but nothing changes. And this one I can actually calculate. 4 squared is 16. 16 times 1 is 16. Final answer. So 1 over 4 to the negative 2 is really just 16. All right, you guys are going to practice a couple of these. I want you to simplify both of these without decimals. So I don't want any decimals. So on your own, I want you to simplify both of these problems. Then check with your partner, see if you get the same answer, and then we'll have some people do it on the board for us. Space them out a little bit more. Right. So on your own, simplify both exponents so there's no negatives. When I say simplify, I mean get rid of negatives in your exponents. That's what it means to simplify. I'll give you about a minute, and then we're going to choose people to do it on the board for us. Yeah.
With the bottom one, the 10,
So you got it right. So you flip it, right? After you flip it, the negative goes away. Negatives go.
So
You
you're
flip it,
just,
it's the opposite.
so just the 10, okay.
So 1 over 10 to the 3. 10 to the 3 is not 30. Okay, 30. Yep. And now you can plug in 10 into the decimal, right?
Yeah.
So plug that in.
Oh, that's my answer.
So as you simplify, get rid of your negatives, and then if you have a number to a power, like 2 squared, actually calculate that. So we'll look at them here in a minute. I'll give you about 30 seconds, finish it off. If you can calculate it, calculate it. If it's an exponent and a power, just leave it, that's fine. Alright, let's pick somebody random. Alright, to start us off, Magi, pick one. Pick one, and you're going to do it for us.
You heard it.
Pick problems, let's fight for us. Let's pick them. Alright, Magi's going to do the first one, or this, I guess it doesn't matter, you can do whatever one you want. Let's pick. Oh, that's too bad. You can do it now. Alright, pick problem. What are you doing? Alright, yes.
Technical difficulties.
Just because you can't write with it doesn't mean it's not complete. I don't know what that is. But
Huh?
Keep going.
Why?
I need to play by the way. No, just because we're doing a bad job of this doesn't mean I'm not going to pick you in the future.
X.
Yeah. Yeah. Case.
Wait.
And then what's one last thing? That's 1 times x10.
1 times x10.
Yeah.
10.
Just x10. Just x10.
Oh.
Because if you times by 1, does anything actually change?
Are you
Alright, so our first one is x to the 10. Don't sign it. You haven't earned that. You earned that.
God dang it, almost got you.
Alright, Moses, do the next one for us. Because I look when I choose. Alright, Moses, can you do the second one? If you're not sure, do your best. We'll help you out if you need it. Alright. So we make a fraction.
What the heck?
What is that?
It's a 10.
I guess. Just
No.
throw out the negative sign.
Yep, alright, it's looking good, but we can keep
That's
going.
the negative sign.
You don't need a negative sign. No,
I'm
just
just
touch it.
trying to get it right, Goki.
Cocky.
So we get 1 over 1,000. Because 10 to the third is 1,000. 1,000 times 1 is still 1,000. Don't sign it.
Yeah, but I'm running that right.
This was like pristine. I'd let you sign it. But it's not. It's not pristine. Alright. This is basically what we're doing today, but it's going to be a little, not really tougher. They're just going to be a little bit longer problems.
Oh my god.
So, we're going to simplify 5a to the third, b to the negative 2. When we simplify, I want to get rid of my negative exponents, and I only need to change things with negative exponents. So, as I look on this one, let me just write it so it's a little bigger, so I can kind of work with it. I got 5a3, b to the negative 2. Okay. As I look through this, I'm only going to switch things with negative exponents. Does 5 have a negative exponent? No. So I'm going to leave that where it is. Does A3 have a negative exponent?
No.
How about B?
Yeah.
The only thing I'm going to split, the only thing I'm going to switch is this B to the negative 2. So I'm going to make my fraction, and I'm going to put B to the negative 2 on the bottom. So on top, I'm going to keep my 5, and I'm going to keep my A3. On the bottom now, I have b to the negative 2, but when it flips, the negative goes away, or I just got b squared. And then I just need to double check and make sure that I can't do anything else. I can't multiply 5 by anything, I can't calculate a b squared, so I'm done.
Oh yeah.
That's it?
That's it. It's going to get a little more complicated, just because there'll be a little bit longer problems, but this is it. So you only flip what has the actual negative exponents. So let's look at, let's do C together, and you guys will do D and E. So I'm going to go over here and write a little bit bigger. I got 4, C to the negative 3B. So on this one, Alizea, what's the only thing that's going to switch?
C.
Yep. So my C has the negative exponent. It's going to flip to the bottom. Put a fraction bar here. So on top, I have 4. And then I've got B, and then on the bottom, C, and it changes to positive. C3 on the bottom.
Oh.
Alright. Let's, not that tough. You know what, let's make up a, give me a second, I'm going to make up one that's a little tougher. A little funner. So we're not going to do D or E, because I want to make up one. Alright, for your A-class problem, make it a little tougher. Actually, we're going to do,
That's a do not in this class.
we're going to do X, 3, Y, negative 2,
Oh.
Z, negative 4, over 3 to the negative 3, and then we're going to do R2. Alright, for your in class problem. I want you to simplify this
That's
one I
an
just
R?
wrote down. Yeah, that's an R. This is an R right there. That looks a little nicer. Moses and Luis, what did I tell you about that thing? Don't mess with it.
Don't go
Alright.
on it.
So, on your own, I want you to do this problem on the board. Don't do D or E, they're too easy. Gotta make it a challenge.
Mr. Donkey.
Gotta make you think today. So, do the problem I wrote on the board, then somebody will simplify it.
How's that? Wait.
This is I know it's hard to see, this is an R. Totally an R. Yeah, let me try it again. That looks terrible.
I don't know what it says. Like,
Well, I know
above
what that says.
fucking line.
Yep. So, here we go, there's an R. So this is an X to the 3, Y to the negative 2, Z to the negative 4.
I don't know what
All
that,
So-
I didn't know that, what that line was.
That's a fraction. And the whole thing, and then below it, 3 to the negative 3, R squared. So go through and remember, only change what has the negative exponent.
Three
This
of
is
them
all
have
one
a
equation.
negative.
So 3 of them flip.
What the
Flip everything that has a negative exponent.
Mr.
You could end up flip-flopping the whole thing. Or you can end up flip-flopping like 1 out of 5.
Mr. Golky, come check mine. Come check mine.
Jason, check his.
I'm just like
Mr. Golky, come check mine. I think it's right.
Okay,
Am I,
there's one
am I
thing missing.
close?
Okay.
Okay. Oh.
Mr. Golky right here.
But then, can't you figure out what 3 to the 3 is?
I got you, Golky.
Yeah.
Very close, Lily. Finish off.
Wait, so we got
Some of them.
because so like be 27. This one be 27.
Yeah, maybe 27. But can you do X3 or E?
Alright, I just gotta change that one up. Alrighty. Alrighty. That's actually not so hard.
Yeah.
Okay.
But then you can flip 3 to 3.
Lock me out. Yeah, you were holding it.
I wouldn't know do it right.
You did.
knows ain't yet. You get the same answer. Answer. We started this.
We don't have further.
There you go.
What if we don't have further? We show you.
Figure out between you. All right, let's go over it. Let's go over it. All right, I think we are at Adelia. Give me one thing that's going to change.
Negative 2.
What?
Negative 2.
The y negative 2?
Yeah,
Okay, where's it going to go?
on the bottom.
And what's the exponent going to be after I put it there?
Isn't it like just 2?
Yep.
Right?
Just 2? All right, so we took care of this y. Actually, let's go through. So let's look at x3. Ashlyn, is that going to change?
No. New
Nope.
day.
Let's stay on top.
It's a new day.
All right.
Just another day.
How about this z negative 4? Ashlyn,
What?
how about z negative 4? Is that going to change?
Yeah,
Where's it going to go?
on the bottom.
And what's it going to look like, the exponent?
A 4.
So z4. Ruben, let's look at 3 to the negative 3. Is that going to change?
Yeah.
Where's it going to go?
To the top.
And what's it going to be for your final answer?
No.
All right, when it's on the top, what do you get?
27.
27. Because we flip it to the top and we get 3 to the 3. You can plug that into Desmos and that's just 27. If you can plug it into Desmos, calculate it.
What about the P2? What about the P2?
What about the R?
The R.
It's an R.
Why did you call this
It's an R, man. Alright, so Moses, what's going to happen with this?
It just stays there.
It's just going to stay there. So it's not over here at the bottom.
What
No,
about
I knew it.
Yes, maybe a recap.
Alright, so let's talk about this
That's
real
funny,
quick.
isn't it?
Real quick. As long as you have x to the third, 27 on top, and y squared, z to the fourth, r squared on bottom, the order doesn't matter.
That's
But
lightweight, Golky. It's lightweight.
the order doesn't matter. But generally speaking, the way you want to write it, the like most accepted form, is you go number first, and then you put your variables in alphabetical order. Alphabetical. So we're going to go r squared y squared z4. So it doesn't matter. I won't count it wrong if you don't do it this way. But this is the most correct way because I got my number first, and then my variables are in
That's
alphabetical
how I
order.
wrote it.
So r, then y, then z. So if you did this, you're fine. Don't worry about it. But this is the most correct. All right. That's it. So on your solve your exit ticket, do your 4 problems there. I will turn on Socratic, and then I will put your homework on Google Classroom.